Okay, here are some examples from the Day 70 assignment. A research dietitian is investigating whether the consumption of fish improves the strength of bones in other adults. 200, in older adults. 200 older adults are recruited for an experiment in which half are asked to eat fish at least 3 times per week and the other half maintains a regular diet. The dietitian measures bone density of all subjects at the beginning and at the end of the experiment and calculates the mean change in bone density. So select first the correct null hypothesis. The null hypothesis is that both groups are the same. That there no difference will occur. That I can already tell by look, it's going to be C. The null hypothesis is that the mean change in bone density for the two groups will be about the same. That whatever stimulus you're trying to provide is not going to make a difference. So that's the null hypothesis. Null sounds like no, so like there will be no difference. Everything will stay the same. If the dietitian finds that the difference of the mean changes in bone density for the two groups is not statistically significant, how does the dietitian interpret the results of the experiment? So if there wasn't a statistical significance, then you cannot reject the null. In order to be able to reject the null hypothesis, there has to be statistically significant data. So the ones that are saying that the null cannot be rejected are B and C. So the dietitian must conclude that the consumption of fish does improve? No, does not improve. Since the null cannot be rejected, we cannot assume that what the people were taking would make a difference. Okay, an agricultural researcher investigates a new fertilizer by planting a field of corn using a new fertilizer and another field using a standard fertilizer. So there's two different fields. At the end of the growing season, the researcher measures the cornfield from each plant in the field and then calculates the mean corn yields of both fields. So the null hypothesis would be that there would be no difference, that they would be exactly the same. It's kind of the negative Nancy saying like, hey, nothing is going to happen. No matter what you try, nothing's going to change. So that's going to be this one here. The two fields are going to end up being about the same. If the researcher finds that the mean corn yield for the field with a new fertilizer is greater than the mean yield with a standard fertilizer, and that the difference is statistically significant, how does the researcher interpret the results? Okay, well, if we do have statistically significant results, then we can reject the null hypothesis. So the ones that say that you are allowed are A and B. So can be rejected, and the researcher can now conclude that the new fertilizer does improve. So B does improve the yield. Okay, and finally here, a research gerontologist is interested in finding ways to help seniors who suffer from insomnia. She conducts an experiment in which 50 elderly volunteers are randomly assigned into two groups, one that receives informational brochures about insomnia and one that receives 2 in-person therapy sessions and 2 follow-up phone calls as well on how to overcome insomnia. Both groups are monitored for the amount of sleep that they get each night. After 1 month, the mean change in the amount of sleep that each group gets is calculated and found to be 0.1 hour for the group that gets the brochures and 1.3 hours for the group that gets the therapy sessions. Okay, so the average amount of change for the people that were getting the brochures is 0.1 of an hour from how they used to sleep before, and then for the people that were getting the therapy, the amount of change in sleep is 1.3 hours on average. Like they get positive, so they're getting 1.3 more hours of sleep on average. So first, let's select the correct null hypothesis. Where's my cursor? There it is. Null hypothesis means that the two groups would be about the same, meaning that there's really no difference between the two treatments. Identify the treatment group and its mean, and then the control group. So the treatment group is the ones who are getting the therapy, and that means X bar means average. So the average amount of change for them was 1.3 hours of sleep. The ones that just got the brochures, their change in sleep, they were getting an extra 0.1 of an hour. So this is the difference in means of the treatment and the control. 1.3 minus 0.1 is 1.2. Oh, I forgot to select the control group. The control group are the ones that were getting the brochures. All right. The resampling distribution for the difference of mean change from the amount, the resampling distribution for the difference of mean change in the amount of sleep, given that the null hypothesis is true, is normal. Okay, so we have a normal curve with a mean of 0 and a standard error of 0.5. What interval captures 95% of the differences of the means in the sampling distribution? Okay, so 95% is roughly 2 standard errors away from the mean. So 2 times 0.5 is 1. So you would go 1 to the left and 1 to the right. So the 95% of the differences should fall between losing 1 hour of sleep and gaining an hour of sleep. -1 and +1. Determine the experimental result significance. So the experimental result is significant because it falls outside. Our difference of means was 1.2 hours. So if you fall inside of the error, well, there might have been a difference, but there might not have. There's not enough evidence to reject the null. But now, since we fell outside, whatever we were doing was doing something. So we can now reject the null. And so receiving therapy sessions and does improve actual sleep if you get the therapy sessions.